All right, we are going to start off with the warm-up first. We did a lot of this last class in terms of the quadratic function, okay? So what I have graphed right now is our parent function, okay? That's our parent function. Now we have to identify A, H, and K. So in number 5, what is our A value? Yeah, 1. What is our H? John? -1. Excellent. Remember, opposite of what you see. What is our K value? Yeah, -2. So therefore, what is our vertex? Andrew? Awesome. -1, -2. So before I even graph anything, what types of transformations are happening? Laurel? Good. One. Sorry. Down 2. Okay. Left 1, down 2. So we could graph our vertex. Okay. And you can shift over the points. Okay. Shift over all the points. Left 1, down 2. Okay. Right? So all the points from the parent function shift over, left 1, down 2. Okay. Then in number 6, we have, what's our A value? Andrew? 1/2. Good. What's our H value? Yes. Good. K value? -5. So what is our new vertex? Mustafa? 3, -5. So based on that information, what transformations are happening? Give me. Good. Down 5 and right 3. Okay. What else? Yeah. Sure. No, no. Thank you for saying that. You do not have to distribute. The A value changes the shape. If you were to distribute, you can't do that anyway yet. You would have to expand this out first. Do your exponent in parentheses first, then you would distribute. The A value is whatever's in front of the parentheses, whatever's in front of x squared. Okay? And that's going to change the shape. All right? That's going to change the shape. So, speaking of the shape, what's going to happen? Since we have an A value of 1/2. Yeah, Charlotte. Excellent. Okay, it's a vertical compression. So, I want to show you guys with this warm-up, okay, using our table of values, how it looks just looking at points. Never mind the graph, looking at points, okay? So, if you have a separate sheet of paper or somewhere to write this down, okay, just so you notice the difference, because you will be given points at one part of this lesson, and you would have to transform those points, okay? No graph, just transform those points. God bless you. So this is our parent function, okay, and our new one. Okay. So anytime you have an A value and a K value, which X or Y is it affecting? Which one? Yeah, the Y values. But there's two things happening to Y. So you want to think of PEMDAS then. Multiplication has to happen first, okay? So when you are transforming and you have an A value and a K, you have to multiply your original Y values by that A value first, okay? So that means, what is 4 times 1/2? 2. What is 1 times 1/2? 1/2. 0. 0. 1/2. And then this is 2 as well. Okay? So we just took care of right now that piece. Okay? We took care of the compression piece. Now, if I'm moving to the right, that could happen at any time, because what values does that affect? Yeah. X value. So if I'm moving to the right, what operation am I using? Add, subtract, multiply, or divide. What's happening if I'm moving to the right? If I'm moving to the right. So if I'm going from here to the right. Yeah, Julia. You're adding. So if you're moving to the right, add 3 to x. Okay? So what is -2 plus 3? 1. -1 plus 3. 0 plus 3. And then we have 4, and then 5. So we took care of just now vertical compression, and we moved to the right. The last thing we have to do is do what? Yeah, Rory. Good. So we have these x values carried over, and we're subtracting 5 from y. So what's 2 minus 5? And then we also know this is -3. And then 3, 0 becomes 3, -5, which is our vertex. Then you would subtract 1/2 minus 5, which is what? So those would be your new points. We're graphing. We're finding points. Because majority of times, we just graph the vertex and do a rough sketch. I want to see 5 points. Okay? And you want to see 5 points on Delta Math. You want to see 5 points on any sort of graph that you do. Okay? The reason is it completes the graph. It shows the full shape of the graph. So we have 3, -5. Okay? And then we had -2 and -4.5. Right? Then we had -1. What was our point? +1. -3. Thank you. And that's our new graph. Okay? So you might think, easy way, just graph the vertex and kind of estimate. Okay? You want to show 5 points. Eventually, on homework and stuff, you will be finding the x and y intercepts as well. Yeah, Andrew, question? You could, the original. You don't have to do all the tables. The reason I show you the tables is because you have to multiply first. Okay? Now, a lot of you could do all of this in your head, right? But the changes that are going to make, you can't follow that pattern that we talked about last class, okay? Because you have that A value. Yeah. Yep. Okay. Okay, and as you guys are copying, or whoever's copying that, okay, if you notice, now we have the cubic function. Okay. A, H, and K are also listed here. Okay. A, H, and K are also listed here. Something called the point of inflection where it switches and makes a turn is HK. That's what you're going to want to graph first. Okay? That's where you're going to want to graph first. So, we're going to start this, as we always do, with the parent function. It's up here. And you have this on your pink sheet. Okay. So, what's my A value? The 1. Grace, what's my H? Good. Rory, what's my K? 4. So what is my point of inflection? Andrew? 1, 4. Okay, and again, that's HK. So if I plot 1, 4, how did I go from, what transformations happened going from 0, 0 to 1, 4? Yeah. Good. Right 1. Up 4. Then everything follows suit. Everything follows suit. Okay. Try the next one on your own. I'll leave this up here for reference. What's my A value? What's my A value? Sam. 1. What's my H? Campbell. What's my K? Jackson. -2. And then my point of inflection? Charlotte. 4, -2. So to go from 0, 0 to 4, -2, what transformations happened, Bianca? Good. Right 4. Down 2. How many of you did have that graph? Good. Awesome. Okay. In B, what are some of the transformations happening? What's 1 without even looking at A, H, and K? What is 1? Yeah, Josh. Good. Vertical stretch because of what number? Good. Vertical stretch by 3. What else is happening? Yep, Liz. Remember, the negative means something else. And the number in front, if we take the absolute value of -3, we get 3. It's greater than 1, so we have a stretch. Yeah, Bert. Good. It's reflected. Okay. So, what is my A value, Laurel? -3. Julia, what's my H value? Good. Tori, what's my K value? And Emily, what's my point of inflection? 0, 0. Okay. So since I have a reflection and vertical stretch, both of those affect what values, X or Y? Yeah, careful. It's a vertical stretch and it's reflected. So what's going to change? The Y values, because what do we have to do to our original Y values? Yeah, Grace. Okay. What else? Are we adding, subtracting, multiplying, dividing? Thank you. Yeah, right. Multiply. So what that looks like, if I just take negative 1, 0, and 1, what is negative 1 cubed? Negative 1 times negative 3. 3. 0 cubed, 0 times negative 3 is 0, because that's still our point of inflection. Then 1 cubed is 1 times negative 3 is negative 3. By doing that, it takes care of your reflection and your vertical stretch at the same time. Okay, so what we did is we multiplied the y values by negative 3. Multiplied the y values by negative 3. Okay. Questions? Try C on your own. All right, so looking at C, okay, what is my A value? Lindsay? 2. Finn, what's my H value? Good. Staffa, what's my K value? 1. Gavin, what's my point of inflection? Negative 1, 1. Okay? Negative 1, 1. So, what transformation is happening? What's 1? John? Left 1. Up 1. Anything else happening? Phoebe? Vertical stretch. Okay. How did you guys find other points? What did we do? Yeah. Multiply the y value by 2. So, you got to do that first, right? So, what did we get for 0? What did we get? Zero what? What's our y value? Yeah, careful. Input 0. What's 0 plus 1? 1 cubed times 2 plus 1. 0, 3 is your new point. Okay, so it still follows the same trend. Just going down here. And that's what your graph looks like. Okay, so again, when you're doing this, once you have your point of inflection, you could input, if that's easier, instead of doing the table, and 1 or 2 x values to the left and 1 or 2 to the right. Okay, left and right. Okay, yeah, Liz. Yep, absolutely. You could do that as well. I just wanted to show you by breaking up the tables how the multiplying has to happen first and then the adding. But yeah, you could get the point of inflection, choose 1 x value to the right, 1 to the left, okay, and you could do one more that way, okay? All right, the next graph is our absolute value function, probably the most basic function that we have, because the A value acts like the slope, okay? The A value acts like the slope. And our vertex, very similar to quadratics, our vertex is HK, okay? Our vertex is HK. So we're just going to jump right into this for absolute value. We're not going to find AH and K. You're going to tell me the vertex. What's the vertex? Campbell. 3, 1. So if I know my vertex is 3, 1, what direction did it move in? Brian? Right 3 and up 1. Now, the thing with absolute value, the A value is your slope, okay? A value is your slope. So, my A value is what here? Yep, 1. So that means from the vertex, go up 1 to the right, back to the vertex, up 1 to the left, since it's the same distance. And you keep going. Okay? For B, what is my vertex? Yep, Josh. There's one. There's always a vertex for absolute value. What would it be? And sorry. What's our HK then? So if there's none, what's that numerical value? 0. So our vertex, good, is 0, -3. Okay, because there's no H value here. So it's 0, -3. Okay. What transformations are happening? Someone else. Let's go. Yep. Vertical stretch because of the 2. Good. Vertical stretch by 2. What else? Charlotte. Reflection. Awesome. And Brian, what's the last one? Good. Down 3. So, since we have -2 in front, that is actually our slope. Okay? So from the vertex, we go down 2 to the right and also to the left. We have our graph. Okay. All right, and the last one we have not talked about is the square root function. Moving quicker because it seems like you guys are good to go. Okay, so the square root function, again, our table of values started with the positive. 0, 1, 4, okay, was 0, 1, and 2. The starting point of square root is our HK. Okay, starting point is our HK. So, in A, what is our starting point? Sam? 2, 1. So that means what direction did it head in? Who could name one? Go ahead. Right 2, up 1. Okay. So we started originally 0, 0. Now we're right 2, up 1. Okay, so here's another scenario where you could plug in x values to find your y's. So if I was to plug in 3, 3 minus 2, 1, what's the square root of 1? Plus 1, 2. And I know the trend where from the starting point, if I count 1, 2, 3, 4, up 2, that gives me my other value. Okay, your goal is to choose x values that are, make this a positive number or perfect square. Okay. Knowing what you know about transformations, I want you to try, and you can work with someone next to you, B and C. Go ahead. All right, for B, what is our starting point? Yeah, Andrew. Awesome. 0, -3. So what transformations are happening? Well, down 3. Good. And what else? Yeah, Campbell. Reflection. Okay, so instead of from my starting point, I'm not going to go up 1. So for example, if I plug in 1, what's the square root of 1? Times negative 1? Minus 3? Negative 4. And then if I keep going, if I plug in 4, what's the square root of 4? 2 times negative 1? Minus 3? Negative 5. Okay, how many of you got that graph? Okay, good. All right, for C, what is my starting point? Brian? Careful. John? Careful. Laurel? Negative 1, 0. Remember, your starting point is HK. It's opposite of what you see inside. Okay? There's no K value on the outside. The number in front just affects stretch or compression. Okay? So our starting point is negative 1, 0. Now, if I plug in, next in line would be 0. 0 plus 1 is 1. What's the square root of 1? Times 2. 5, 0, 2. If I was to plug in 2, 3. 3 plus 1? 4. Square root of 4 times 2? 4. And that is my graph. So what happened with this graph? It was one transformation. Yeah, same. Left one. Good. What's another? Yeah, try that. Good. Vertical stretch. By 2. Awesome. All right. So we did go through all the functions. Okay. All the functions. When you guys get back from lunch, I'm going to pass out something before lunch. Okay. When you